Question number 3 says, determine the lengths of the line segments joining the following points. So we're talking about lengths of lines. So let's go to module number 7 with regards to length of line segment. It says the Pythagoras theorem. In a right angle triangle, the length of the hypotenuse may be calculated using the Pythagoras theorem. So the formula for length of line has its origins. The formula for length of line has its origins in the Pythagoras theorem. And here is the formula for it. The length of line formula. It has its origins in the Pythagoras theorem. Here it is. C squared is equal to A squared plus B squared. So let's take a copy of this formula for length of line. Place it in our worksheet. And we can formulate an example. These examples have negative numbers. So we can put negative numbers in our example. Let's say, for example, you've got negative 4, 7. And you've got, let's say, 8, negative 5. Again, we can see that the formula says x2 minus x1 all squared plus y2 minus y1 all squared, the square root thereof. That will give us the length of line. So we have to label the points so we can properly substitute into the formula. We know for sure that a point, it consists of two coordinates, the x coming first and the y coming after, x comma y. So therefore now, we can label this point, point number 1. And this point can be called point number 2. So therefore now, x1 logically looks like negative 4. And y1 looks like 7. x1 and y1, that's for point number 1. And point number 2, x2 now is actually 8. And y2 is actually negative 5. So the coordinates of the points are properly labeled. So now we are ready to substitute into this formula. As you can see, this formula is a little bit more difficult than the midpoint formula. So let's take our time with it. Now you can see that we have a square root sign to deal with. So we insert our square root sign. And then we have a bracket raised to the power of 2 plus another bracket raised to the power of 2. Okay. As I'm doing this, you can do this with the example in the question. So it says x2 minus x1. So in this bracket there, we have to put x2 minus x1. x2 is 8. Minus x1 is a negative 4. The formula comes with a minus already. So it's 8 minus minus 4. All right, pause a little bit and contemplate on this. So we have to be very careful here. The formula comes with a negative sign. So what we can do, we can color code the negative sign that's in the formula. And it also will be here in this bracket. So this negative sign is from the formula. So it says x2 minus x1. x2 is 8, x1 is a negative 4. So it's 8 minus a negative 4. y2 minus y1. y2 is a negative 5 minus, well, negative 5 must be black. Color code is for the negative sign alone. Minus 5 minus a 7. Okay, so be very careful with this formula. It comes with a negative sign already. So therefore now, we are going to calculate what is 8 minus a minus 4. A minus times a minus is a positive. This is not a minus and a minus. That's a minus times because they are facing each other. So it's a times that's going on between them. A minus times a minus is a positive. And a minus and a minus is a minus. So this now is actually negative 5 plus negative 7. 5 units towards the left and 7 units towards the left. So we are looking at 12 units towards the left. Okay? You're taking out 5 and then you're taking out 7. So therefore you took out 12, you know. But here you are multiplying 2 negatives, so that's a positive. So now 8 plus 4 is actually 12, coincidentally. And then 12 times 12 is 144. And a negative times a negative is a positive. So negative 12 times negative 12 is another 144. So we have to add 144 plus 144. That will give us 288. I need to find the square root of 288. So let's see what the question says with regards to the decimal places. Determine the length of the line segments joining the following points. It did not specify how many decimal places. So let's put it to, let's say, 3 decimal places. So we have to find the square root of 288. So we can use our calculator, equal to square root of 288 equal 16.971. So we end up with 16.971. Because after the 1 is a 0 and there's a 5, so 16.971 units length of line.